Hey guys, we're on Unit 2. This is day 6 called Proving Identities. So an identity is basically an equation where the left side is equal to the right side. And it holds true for all values of the variables that are plugged in. And when you prove an identity, there's a couple directions that you got to follow. First off, you got to separate the sides. We separate them with a line anyways to remind us that it's almost like a wall where you cannot cross it. You cannot bring terms from the left side to the right side. Everything that's on the left side has to stay on the left side, and everything on the right side has to stay on the right side. There is no canceling anything out. You basically can put things together with multiplication. You could take things apart with factoring, but that is about it. And then eventually at the end, when you show the left side equals the right side, you proved the identity. You proved that the left side equals the right side. So here we go. In number 1, it says algebraically prove that x squared minus y squared equals x minus y times x plus y. So sometimes you can tweak the left side, sometimes you can tweak the right side, sometimes you have to tweak both sides. It depends on the problem and it depends on what you see. So for instance, in this one, I could tweak the left side because I noticed this is a D2PS. I forgot to put up my wall too. So let me put up the wall to remind myself I cannot cross it. Okay. And since that's a D2PS, we could go ahead and factor it. That D2PS would factor into square root of x squared is x, 1 with a plus, 1 with a minus, and the square root of y squared is y. And if you notice, we did it. It doesn't have to be exactly in the same order. But that's it. The left side equals the right side. And you can also even write left side equals right side. And you could be done. Okay, let me just show you. I'm going to erase and show you just a different way of doing it where you don't tweak the left side, but maybe you tweak the right side. So I'm going to go ahead and erase. That was just one way of doing it. And sometimes you have an option, sometimes you don't. You just have to look at what you're being given. All right, so again, I'm going to put up my wall, but this time I'm going to go ahead and leave this side as x squared minus y squared. On this side, I'm going to put these together, and some people like the little box method to put them together. And so you could do x minus y up top, x plus y on the side, and you could fill it in, or you could do the little rainbows. X times x is x squared. This would give you a positive xy. This would give you a negative xy, and this would give you a negative y squared. And here, the two middle terms are like, and they would go together. However, they are opposites of each other, and they would cancel each other out. And so this left side just comes down, equal to the right side, which is x squared minus y squared. And there it is again. The left side equals the right side. And that one is finished. Okay. Let's see what else they got. So again, you could tweak either side there to get the left side to equal the right side. Sometimes you can, sometimes you can't. Okay. So in number 2, it says algebraically prove that that fraction is equal to 1 plus that fraction. And it says where x doesn't equal negative 2. And they have to tell you that because if x did equal negative 2, and you don't really have to pay too much attention to this, but it would make those fractions undefined. And so that's why they have to tell you that in order to make it like a valid identity. Okay, but we don't really have to do anything with it. All right, I do notice something. Well, first off, let's put the wall up to remind ourselves that we cannot cross over it. This little one here, he does not have a denominator, and it does look like a fractional equation that we just got done with on day 4 and day 5. And so if we go ahead and give him a denominator, we're going to notice that these denominators are already common. And so all we need to do is give this one a common denominator. And so we'll give him the x cubed plus 8, top and bottom. All right, so I think I'm going to go ahead and leave this side just the way it is. So I'm just going to drop down my fraction of x cubed plus 9 over x cubed plus 8. And we're going to have our equal sign still. This fraction of 1 over 1 is now going to become x cubed plus 8 over x cubed plus 8. And this fraction is going to stay the same, plus 1 over x cubed plus 8. And now that they have common denominators, those two fractions are going together. So this side's just going to drop down. So you see that I'm not tweaking this side at all, like I did in the first time I did the first one. Okay, but now because these have common denominators, we're going to keep that common denominator of x cubed plus 8. And we're going to go ahead and combine the tops. And if you notice on the tops, when we add them together, those are going to be like terms. Positive 8 plus 1 is going to give us a positive 9. And so we'll have x cubed plus 9. And there it is. The left side equals the right side. And so this one's finished. Okay, let's check the next one. Looks like another fractional equation. And again, they have to tell us this. X doesn't equal 0, because if it did equal 0, it would make your fractions undefined and we wouldn't be able to do this problem. You don't have to really do anything with it. Okay, just realize what they're telling you. Okay, so we do not have common denominators in this one. I'm going to go ahead and put my wall up to remind myself that I cannot cross this. And it's looking like our LCD highest number is 4, and 2 goes into 4, so we'll keep the 4. And x and x squared, so we're going to have to make it x squared. Okay, so this first one is going to need the x, top and bottom. Second one is going to need a 2, top and bottom. And that one already has the 4x squared. Okay, and so if we look on the left-hand side here, we're going to have an x over 4x squared. Keep the plus sign. That's going to be a 2 over 4x squared equal to an x plus 2 over 4x squared. So on this one, we're tweaking the left side and we're leaving the right side alone. Okay. Also, remember that I said that you cannot cancel anything out. Normally with fractional equations, we once the denominators are the same, we just pay attention to the tops or the numerators or the equation in the numerators. In fractional equations, you cannot cancel anything out. Everything has to stay. Okay. So now that these common denominators here are on the left-hand side, we can go ahead and combine those two fractions with the same denominator of 4x squared. And across the top, we would have x plus 2. Those are not like terms. They don't go together. However, we can squish them together like that. And if you notice, that's the same exact thing on the other side. And so our left side equals our right side. And we're finished with this one. Okay. All right, take a look at the next one. Last one on this side. Looks like another fractional equation. Hopefully you're getting used to them by now, and hopefully you understand why they're telling you x cannot equal -3. If x did equal -3, it would make your fractions undefined, and we wouldn't be able to do this problem. Okay, go ahead and put the wall up so that we make sure that we do not cross it. Okay. And we have that one situation here with that 1 who does not have a denominator, so we're going to put him over 1 to give him a denominator. And you can see that some of our denominators are already the same, and so all this fraction is going to need is the x plus 3, top and bottom. Okay, so taking a look on our left-hand side, that first fraction is going to stay 2x plus 4 over x plus 3. Notice that minus sign in there. Be careful, he's tricky. We're going to turn him into a positive, and we're going to make that negative go closer to the 1. And so when we take that -1 and we distribute it up here, we're going to go ahead and have a negative x. And if we distribute it again, we're going to have a -1 times 3, which is -3, all over that denominator of x plus 3. Keep our equal sign, and we are going to leave this fraction alone. So again, this time we're tweaking the left side, leaving the right side alone. Okay. All right, so now on the left-hand side, that they both have the same denominator of x plus 3, those two fractions will go together. And if I go across the tops, there are some like terms up here. We have a 2x minus x, which is x. And we have a positive 4 minus 3, which is positive 1. And there it is. Left side equals the right side. And so this one is finished. All right, I'll see you guys in the back of the notes.